Hopefully everyone can hear us now. I'll quickly go through what we did before, but sorry, once again, afternoon, and apologies for the delay. But firstly, I'd like to acknowledge the traditional owners of all the lands across Australia and other countries in which we are gathered, and pay my respects to the elders past and present. In particular, I'd like to acknowledge the Gadigal people of the Eora Nation, on whose traditional lands we are speaking from today. Mindful of time, I'll quickly just run through a couple of things. So we've got, over the last few years, we've seen a number of events where the conduct of contact centres has been called out for misconduct on sales practices, poor policy administration practices, and claims management issues. We've seen a range of drivers for these issues, from cultural issues, inexperienced teams, and management oversight. Today's session is co-hosted by Swiss Re and Deloitte on the use of AI for the contact centre conduct risk detection and demonstrate a customised voice analytics solution that supports conduct risk identification as part of a large-scale remediation program. We have three presenters today, so Mike Folds, Dr. Leah Worth, and Pratik Mahanas. Mike is Head of Actuarial Management, Life and Health at Swiss Re Australia, fellow of the Institute of Actuaries, and a member of the data analytics team. Dr. Leah Worth is the lead trustworthy AI partner for risk advisory within Deloitte. She's been a partner with Deloitte since 2021. And finally, we have Pratik Mahanas, who's a director within Deloitte's risk advisory practice with ongoing advanced analytics and data science within the financial services industry. With that, I'll pass on to Mike to talk through.
Okay, so I put myself on unmute, but just someone shout if they can't hear me. I'm going to give the cliff notes of this problem statement because I've just stated it a few minutes ago, but we're not focusing on the details of the remediation exercise, just take it that we were doing one. We had 80,000 customers and we invited them to call in if they felt that there was an element of their interaction that had not gone well, and we had a large number of responses, something like 5 times as much as we originally expected. And so for the purpose of this project, we had to manually review and listen to all the conversations with these customers who chose to opt in. And due to the complexity, consistency, and time implications, the existing approach, or the original planned approach of listening to all the calls, was not deemed fit for purpose. Pratik, if you want to go to the next slide. So very complex exercise. We had to review a large number of voice records, as you could see from the previous slide. For every person who opted in, there were dozens, or there were often multiple interactions. So we were looking at something like 900,000 calls, 100,000 hours of material. We had this product had been sold over a period of 10 years, so we had multiple legacy telephone systems. We had multiple voice recording formats. We had the quality of the metadata wasn't always perfect, so it was challenging to even identify the timing and the calls and which customers they're related to. So the issues were very, very complex and required significant understanding of the context and the behavior of the agents. So the case assessors that we had needed to be pretty skilled. We looked and we searched for basic keywords and phrase libraries, and the problem with that is we had a significant number of false positives. And on top of all of this, the burden of proof to confirm absence of conduct issue rested with Swiss Re. So this was quite a steep challenge. Often you find that confirming the presence of an issue in a call is much easier than proving the absence of misconduct. So that was the complexity of the issue. So the issues under review, we had to look for a number of different potential problems. So in the top left, we had the potential issue that the agent had provided incorrect or misleading information. Sometimes we had customer hesitancy and affordability concerns, and this wasn't necessarily something that was overt. It was something that might needed to be that was implied and needed to be sussed out. Sometimes the in certain scenarios, the customer was clearly distracted, and so which led them to not understanding if the product was fit for purpose. Sometimes the agent said the right things, but said it in a very rushed way, didn't allow the customer time, yeah, sometimes the sales practice was overly aggressive, and again, not necessarily in the words that were said, but the way that they were said. So next slide. So what was the potential solution? We needed some sort of AI-driven platform that could automatically detect and point to high risk within cause that the assessor could then follow up on. And always with this, the priority was to put the customer first and to enable consistency in review. So this wasn't just about cost saving or efficiency. It was also about trying to get through a very large number of calls and with the customer front and center. And the solution had to be able to handle a very large number of calls, to evaluate and compute in order to service a large pipeline of case assessors. And the solution we came to was an AI-driven natural language processing solution. And the solution infrastructure had to support machine learning and data processing requirements. So, yeah, that's all I'll say on that one.
Fantastic. Thank you very much, Mike. And thanks for having us along to your Actuaries data group today. Pratik and I are data scientists, not actuaries, but we do have Brendan and Mike here to keep us honest and on track. So we're going to dive into some of the componentry and the approach that we took to resolving.
Apologies.
Oh, yeah. All right.
Yes. Okay, excellent. Costume change. All right. Excellent. Okay, thank you very much. I'm going to talk through the approach that we took to resolve this problem and support Swiss Re. As Mike mentioned, it was an enormously complex yet important problem. One from the really focusing on the user-centered experience, and that is making sure that we supported the case assessors in the identification of potential risk within a huge amount of calls that came through. Additional complexity surrounding this was that the telephony systems, there was a number of telephony systems that had been used across the different phases heading into the program. So we did need to unpack and extract data from multiple systems that some of them were quite aged and some of them did have issues with metadata, as Mike mentioned there. Of course, this being a remediation program with oversight of ASIC is ensuring that the construction, the extraction, the use and the outputs of this analysis was very tightly controlled and governed and documented. So just going through the process here is we did extract the calls from the legacy systems there into a cloud environment where we were able to build out our models, which Pratik, being our chief data scientist on this side, is going to take you through the detail of that. Once we had extracted and loaded the calls into AWS, our cloud platform, we really treated the calls as a set of unstructured data. So we were able to not only look into the content of the calls, but we did have then access to agent notes and the ability to run the models over multiple forms of customer interaction and unstructured data. The models that we did build out for the identification of potential misconduct, initially the first thing that we did was transcribe the text, the calls into text. And this was it was a really interesting process in that I think one of the, we used initially we used off-the-shelf transcription systems, which were not particularly accurate. One of the first calls I listened to and read the transcripts as we went through was, "Hello, I am a violin." So not a great user experience and not a great support for the case assessors there. But the team then built out tailored transcription models specifically for this use case. So it was bringing it into tailoring out those transcription models to unpack and understand the content and context of calls within insurance, sales, and retention and support. Once we had the extraction into text, we then developed NLP models to identify we built the NLP models firstly to understand, computer understand the content, so the semantic meaning of the content of those calls. It was the ability to, Pratik will take you through the semantic vectors and all of that fun stuff, but it was really breaking it down into sentence by sentence, and not just looking at the words that were spoken, but how those words come together to give meaning to a sentence, and therefore an interaction. The outputs that we provided back to the agents were a transcription and an audio player, which was really interesting because we knew that transcription would provide an efficiency just in the ability to read through rather than listen through. Humans are much faster reading than they are listening and consuming language. But when we had feedback from the case assessors, it really helped with fatigue. Sitting and listening to calls all day, every day is a pretty exhausting experience. And the feedback that we did get from the case assessors was it really helped in terms of fatigue management and focus and concentration within the contact centres. So once we had the transcription, we built the models to identify the potential risk and misconduct. And each time a case assessor viewed the flag for potential risk, they then were part of the feedback mechanism and the training process for the machine learning models. They would flag that yes, it was accurate, or no, the flag was not accurate, which we went through a weekly process of uplift and refinement of those models that gave us ever more increasing accuracy for the execution and identification of those flags. And then we presented this through dashboards. And rather than me just talk about the dashboards, I am going to provide a demo. How many computers can we fit on a desk? We're going to talk to one. I'm going to manipulate another one. Let's do this. Okay, so I'm looking up there. I'm doing this over here. Okay. Oh, am I going up there? Where do I put the mouse? There we go. All right, excellent. So they can see the dashboard?
Yeah.
Excellent. Thank you. Just checking. All right, so what you can see here is an example of the dashboard that we provided for Swiss Re for the identification of potential misconduct within calls. As you can see on the screen here, this is a mock-up, but it's Mike could agree it's pretty accurate considering a reflection of what was provided back into the program. For each of the customers, there were multiple calls associated. You know, as Mike said, sometimes there were dozens and dozens of calls associated to a particular customer, and misconduct could have occurred in any one of these. So we were really looking to facilitate efficient identification of where that misconduct may have occurred. And as you can see on the screen here, these represent the calls that have been either made or received. And over here are the flags against those calls, indicating which of those calls might have presence of misconduct. So we'll go into the first one here, which is obviously of interest. So the dashboard itself is really, it tells a story in of itself. Over on the left-hand side here, we have the flags. As Mike took us through, there were multiple incidents or types of conduct issues that we were looking for. And the machine learning model identified the points at which within a conversation which may have occurred, and then a tagging of what type of issue that might have been. And just before I go into playing this call, is just, you can immediately see here up the top, there's a timeline with the talking of the agent versus the customer. And this is another really nifty thing that the team pulled together, was the ability to identify who was agent and who was customer within the call. And we can see right up here that the agent was really a barrage of words and information, with the customer a relatively reluctant speaker and not particularly engaged within this call. So rather than listening to the whole call, first we can just go straight to the point in which the call that we're interested in. So it takes us right down here, and
well, I don't know whether
was
I can
working.
afford that.
Yeah, well, I was going to say,
Tested
the other
it.
option is
Tested it.
look at either
All right,
reducing
I'm
the
going to give you like that. You must have messed around with the features to try and put people here.
Stop sharing. Oh, no, they could hear it.
They could hear it.
Okay, we just can't hear it.
We can.
Okay.
All right.
I
Well,
think that system is not working, so we're not getting any output.
okay. This is some flying blind. All right. Awesome. Okay. So, all right.
Just play it for a random number of
That's
seconds.
right.
It just isn't hard.
Okay. Well, at least we've got the important people hearing. All right, so we've hit the affordability here. It takes us right to the point in the call where we've got an affordability flag. I am going to play it. And then we flow right into the agent's response here. Was,
yeah, well, I was going to say, the
here,
other
not
option is
listening
look
to,
at either
the
reducing the
customer's
cover closer
response.
to 11 months or
We can
12
go down
months,
to the next
or I
point
can give
in
you,
the
we can
call.
do
So
reduce
if
the
you can
cover. I
write
could reduce
from
the amount of
around
cover,
the 10
I don't
minute
know,
to the
for,
12-minute mark.
say John or maybe the kids,
Again,
or
we've got a
what you can
statement
is
of
the first 12 months, and I know it sounds like a
affordability,
bit of
and again, we've got the agent coming back
Knowing all that, I
immediately with
forget to
a
cancel it.
pressure
No,
point
see,
around
the thing
that.
is, we give you a call, and we also send you out reminders.
Sorry. Okay. All right, but I think they've got the gist. I think they've got the gist. So that was the first call here. Again, it's the ability to very quickly and easily see the flags, the point in the call. You can see that this occurred 10 minutes in, so you're immediately saving those call assessors 10 minutes of listening up front before you jump right in. I'm going to show you a second call here. And I won't talk over the top this time. All right, so it's a a similar call in terms of identification of the flags, the risk issues here, identification of the agent's response and activities. But with this one, rather than just kind of going to the top again, like we can see with the first affordability flag, we've got a clear statement. All right, time to put the glasses back on. We've got a clear statement about afford. We're saying here afford. So that's really, sorry, Pratik, but that's not very fancy when we identify actual words within the text. Because really the power of the NLP models that we built is understanding the context and meaning from the array of words that are come together in a sentence. So I'm going to go down to this one here. All right, so this one, I'm going to play this.
Okay, I'm not sure about this. Like I said, there's not very much money in my bank account,
So
and what I
for
want
that
to do
one,
is
you'll
cancel the
have heard
policy.
there was no
But as it's free,
statement of
perhaps I'll keep the
affordability. The only way you can get a sense that there is an issue with affordability, I mean, you look at money, yep, that's an indication, but money by itself or bank account by itself is not a good, it's going to give you many false positives. It has no meaning. It only is when you bring together a construction of words around that, which is not very much money, in context to the broader conversation, is we can see that we're unpacking the sentiment, the meaning of those statements that sit within. So I might pass back to, I actually have to physically pass back to. There you go.
Thank you very much. So what was the outcome of this this exercise? So speaking now as the voice of the client, Deloitte had supported us with this tool. As you can see, we have a graph showing the weeks of the project, how many cases per day per assessor the case assessors were able to achieve. And you can see that it was pretty tough going at the beginning. After about week 11, we started to get the transcripts up and running in the tool, and we got some slight improvement in productivity, but it was really when the machine learning models were deployed that we really started to get some dramatic improvements. So we were very pleased with the outcome at Swiss Re. We saw an improvement in efficiency and cost, but more importantly, I think we also saw an improvement in the customer outcome. So there was better accuracy. Just the fact that we were getting through the exercise quicker had benefits for customer, and there was an improved simplicity to the process, just the coordination across the many case assessors that we had. So that was the thing, and you can see how the process improved over time. So there was a feedback loop as we trained the models, as we got used to working between the manual follow-up versus the computer-driven aid, and we saw improved performance over time.
Is it
cut
what's
across?
hand back
Yes.
again?
Yes, I was back to you.
Thank you. Can you just go back up again, Pratik? I love this graph. I just love this graph so much because we talk about feedback loops. We've talked about training the models, and this is a graph where you actually see the models being trained. You actually see when they've been released, and it actually, there's a slight dip there because the case assessors were beginning to get used to the new technology. But then week on week, as the case assessors were feeding back the results and inputting to those machine learning models, we just got more and more accurate as we went on. That's one of my favorite graphs. Thank you. All right. So just a quick summary of the potential uses of these models. We really see that there's strong applicability within the contact centre. So whilst we use this one to support a remediation program, it was very targeted. The ability to apply this technology within contact centres for risk and compliance, compliance with regulatory obligations, the reading of PDSs, the accurate collection of identity information. From that perspective, we're really then being able to take quality assessment teams that traditionally listen to about maybe 1 to 3% is what we've seen in the industry to get that sense of quality assurance. We're now able to apply that to 100% of the calls, with the quality assurance teams then being able to focus on those calls that are at the highest risk for non-compliance. And customer experience is, we really focused on the identification of potential non-compliance here, but the ability to identify vulnerability, the ability to identify sentiment, anger, hesitation, and be able to then tie that back to particular agents within call centres or contact centres. It then allows, on both sides of the coin, it allows further training opportunity for those contact centre staff who are not associated with the most positive experience of customers, but also it can identify those contact centre staff that are amazing and have really high positive satisfaction and sentiment results associated with their calls. For provision of training and use of those examples more broadly to this. And through this process of really bringing that unstructured data together and being able to unpack and analyse the themes that are emerging from this, and then tie together with the next best action, so the downstream processes, is we can pull in that robotic process automation to really ensure that we make those experiences as efficient as possible. Because I think that everyone can agree that no one particularly likes calling in to contact centres, and the more efficient we can make those, the better we can be. Thank you. So I'm going to so this is the geek section. So we've been it is the geek section. Yeah. It is, so we've been, it's been fantastic having Michael on to give that really good sense from the business context. I've given a pretty high level overview of the approach that we took from cloud technologies, machine learning techniques and tools, the dashboarding and the interactions. But this is Pratik's opportunity to get geeky, which I know he loves. So I'll pass over to Pratik.
Thank you, Elia. And Elia always keeps me in check because I tend to become too technical. But I'll do my best to
You're off the leash.
to talk as plainly and as possible about the use case. So as Mike and Elia mentioned, the use case presented a unique opportunity. The use case presented a unique opportunity for us to build a voice analytics engine to drive very specific outcomes. Now, just being mindful of the fact that this was built over an existing infrastructure layer, which was driving the traditional program, which is a lot of data and technical architecture sitting over various layers. And AWS in that sense was not part of our infrastructure. So one of our first challenge was to how do we seamlessly integrate a new data environment at the same time taking care of the complexities of data security, which is obviously a very important topic these days, but also make sure the experience going out to the end users, in this case, the case assessors, was effective and seamless enough that they're able to use this tool very effectively. Now, from a process perspective, what was happening was that customers were calling in, the program was reaching out to the customers on a daily basis, and some of those customers were asking us to review their calls. This was happening on an ongoing basis, and the case volume actually, because of the response rate, which Mike mentioned was 5 times the expectation, it actually, there was a huge backlog of cases to be evaluated, and the human intervention over here was taking a lot of time. So what we had to do was essentially pick up all the backlog of cases, as well as daily customers who were opting into the program, and create a system of transfer of information to the cloud environment in a way that we are able to process the cases which are in scope for that particular day, and then output the results in effectively a 24-hour time period, so that the case assessors can essentially start looking at those cases the next day. Now, this essentially obviously meant that we built quite a complicated data pipeline traversing through multiple systems and multiple technologies. And essentially, there were a bunch of cloud engineers, data engineers, and data scientists working together to bring it seamlessly together. Once the calls were in the AWS environment, then the machine learning or the NLP bit kicked in. The first being the language model, which was essentially the transcription part of it. And to Elia's point, the key feature or the key enhancement that we did over there, that we took all the product disclosure statements which were associated with the product, and we fed that to the machine to understand this is the terminology which you need to be understanding in the context of. So, for example, the initial transcript said, your salmon shore. After we fed the PDSs, it became your sum insured, which obviously makes much more sense in the context of things that we are looking at. So the language model was effectively able to better transcribe the relevant context of the conversation. And then the biggest challenge in any problem such as this is training data. And as you may imagine, the training data was unstructured voice calls, which presented a challenge that we did not have a starting point. Fortunately for us, we already had few case assessors onto the project who had already listened to calls. So we created a UX environment within AWS for us to actually use the already reviewed call to create the initial set of training data, which essentially meant that we took a few hundreds and thousands of calls just as a starting point. So that solved that training data problem. But as you can imagine, that was not, with the volumes that we are talking, it was not large enough for us to build very robust models. And that problem was solved by the feedback loop, wherein we created an initial set of outcomes from the modeling perspective, which were then fed to the end users, which were case assessors. And we crowdsource our training data generation to those case assessors, because they were very easily able to tell us, yes, this inference that the model has put out was accurate, and you picked up the right thing. And in the cases where it was, not relevant or out of context, they were also able to disagree with our findings to say, no, this is not the right way. Now, what that did, that over a period of 3-4 weeks, we suddenly generated a large number of data points, which could be then refed into our modeling pipeline. And essentially, that's the graph that you saw, where as we started collecting these thousands and thousands of inferences coming back from the case assessors, the model performance started improving. So essentially, it became an exercise of crowdsourcing that training data generation while the team is performing their day jobs. And we were able to sort of realize that efficiency out of the whole process as well. Now, we obviously had to build an elaborate machine learning operations pipeline for this, because as you can imagine, the models were retrained every week. So the entire modeling pipeline had to be carefully managed, governed, and deployed in an automated fashion, with obviously the requisite governance to make sure we only deploy models when we are realizing a benefit. And what we saw was that after about 8 weeks in, that benefit started tapering off. So basically the models had tuned to the best possible state. And after that, we saw that there was not much information being added on as well, which is why at the end of the program, it actually stabilizes from an accuracy perspective as well. And this, as I said, this feedback loop was absolutely critical for us to be able to deliver these models really effectively and efficiently and drive the outcomes that we are looking for. I will go to the next slide. So I'll talk very quickly over the key modeling techniques that we used here. In terms of, we obviously had multiple conduct issues that we were trying to decipher, as Mike indicated in the previous slide, and there was no one solution which fit everything. So depending on the conduct issue, we developed a hybrid state, which was a combination of multiple models put together to come up with a reasonable risk score to identify a conversation or spoken by an agent or a customer as detriment or not. So one of the key identifiers that we had to put in was, first of all, identify who was speaking, because if the agent is speaking versus if the customer is speaking, because the context is so different, you could generate a lot of false positives by if you don't identify the speaker accurately. And the way we did that was, obviously during a customer service or a sales calls, the agent tend to speak a regular expression which are closely monitored. So a lot of times that was actually driven by regex, but in case that regex was not present, that we also used non-voice features to identify the speaker acoustics, which essentially meant the speaker which was dominating the conversation was more likely the agent, and the person who was more of a passive speaker or a more of a listener was the customer. Combining these two pieces, we were able to identify who was the agent, who was the speaker. And then we built what we call a semantic model. We used word embeddings in here using deep averaging networks. And I'll not go into the geeky stuff, but basically we converted text into vectors or numbers, which can then be parsed into machine learning models. So essentially we use TensorFlow use models, which is an open source model, universal sentence encoder, which essentially converted each and every sentence into a 512 dimension vector. And then we had already designed canonical sentences, which were very key indicators of detriment. So for example, if the customer is saying, I want to cancel my policy, that's your canonical sentence. We then compare this sentence to everything which the customer has spoken. And if we find a close match in terms of meaning with this sentence, that's what we identify as inference. So it was done based on a cosine similarity score between the two vectors, which essentially becomes a normal mathematical problem as opposed to, understanding words and meanings behind that. Another interesting model that we built was the FSM model. So now this, even though semantic models identifies whether a particular sentence or a meaning was spoken or not, within a conversation, you could actually say more words or sentences which could mitigate the risk which existed in the initial sentence. And essentially, you had to contextualize the spoken words in the conversation just to be able to say whether this is misconduct or not, because the agent might have said something, but then also sort of qualified that sentence with a disclosure, or would have said something which actually, neutralized the impact of the initial statement. So finite state machine essentially that we built is that from a sentence to a detriment. So let's say a sentence is spoken that indicates a detriment. We track what happened afterwards. So in that sense, if the agent says something which doubles down on the detriment, we provide it an additional score to say, okay, this is more risky. If the agent says something which either neutralizes or diminishes the impact of the first statement, we either give it a slightly, we subtract this score from the original score, or we actually make it 0 if what the agent said was really impactful in terms of destroying the meaning of the previous sentence. And this essentially allowed us to create a sequential score of the spoken conversation to say whether the eventual meaning of the entire conversation was leading to detriment or not. And this essentially helped us bring together multiple different techniques, but also developed a very deep understanding of what the agent said, what could have been wrong, and whether did they mitigate that or not. We also built statistical model. This was your standard SVM based on stochastic gradient. This was a typical machine learning model with a 1-0 flag. We obviously had training data, and essentially we used TF-IDF for the technical people, which is essentially converting the words again into a simple data matrix and then doing binary classification on that. The final model we had was temporal models. This essentially was more about the spoken language and rate of speech of each of the agent and the customer. And this was essentially a lot more linguistic in nature. So we had interesting conversations about how does a vowel define a syllable, how many syllables a person is speaking in one go, and how they are dictating a particular conversation, which led us to what was the engagement for a customer perspective. And then obviously we boxed them into scores that if the customer has spoken or interacted less than a particular level, then obviously we will consider the agent to be too dominating, or if the customer is fairly engaged or not. As you can see on the charts below, the initial accuracy numbers from an F1 score perspective were quite low because we were dealing with very low amount of training data. But as we started increasing the data points based on the feedback loop, we see a consistent lift across all the different kinds of models that we are building. Obviously, we've not indicated all the model outcomes here. We just getting to the final state, but this was the journey from a accuracy perspective of what the models were undertaking. Yeah, so that's pretty much it. There's a lot more I can continue to go on, but I think for the purposes of this session, I would just take a pause now and open the floor for any questions. Of Brendan, if you would like to add something. Okay.
Yeah. Thanks, Pratik, Mike, and Aliyah. Aliyah's had to apologies and pop out. It's really insightful. I think there's a couple of questions on the Q&A log that we might come to in a second. But it's probably, I'll start off with a couple of questions myself. One of the ones I find interesting is you talk about you've got the agent versus the customer. Now, was that based on a single channel audio recording? Was that based on a dual channel?
No, actually we had both. So as we mentioned, sorry. Yeah, it was actually based on both. So because this was a long time period and the quality of the voice technology has evolved a lot in the last 10 years. So the initial part of our cohort was actually single channel, but eventually, obviously, we had multi-channel conversations as well. So the models, and obviously, as you can imagine, the accuracy in transcripts in the initial periods was a little worse than what we saw in the multi-channel because it was very clear who was talking in the latter years. Cool.
Yes, probably then one for you, Mike. We know that this was a very regulatory-driven project. So from your view, in terms of the engagement with the regulator and their thoughts on the outcomes of using this as a way, is there any insights or anything you want to talk to?
Yeah, I mean, there was obviously a human overlay. So particularly with cases where conduct was an issue, there was an assessor that had assessed that at the end of the day. So there was regulatory comfort with that. The challenge, of course, was where we had said there was no misconduct and we weren't going to have a human go through the call. So that was I guess the hurdle. But the other side of the story is just how much quicker we were able to do the exercise and the coverage that we were able to achieve. So instead of 1 to 2% coverage, we could say that we were doing 100% coverage and get through the program that much quicker. That was very well received.
Yeah, I think that the coverage ability and to be able to get that 100% So really important for a remediation program. Then when you go back for a sort of ongoing monitoring of new engagement, that becomes even more important. There's one last question, I think, from online. So Pratik, I don't know, it's regards to the balance in the positive and false negatives. So I wonder if you wanted to answer that.
Yeah, sure. So that's an excellent question. And as you may imagine, initially there were a large number of false positives, but there was one additional thing that was working in our favor, that this was not a decision engine. This was the inferences or the model outputs were at a conversation level. So in a long conversation, we were providing inputs, whether a particular sentence or a conversational point indicated detriment or not. We achieved a reasonable accuracy in terms of detecting specific conducts, and obviously different conduct issues had different accuracy. And this was validated by the feedback coming in on a weekly basis as well. So the initial feedback was we are obviously not doing great in terms of accuracy, but because we were generating so much data on an ongoing basis, that enabled us to actually keep testing our models, that how we are doing in terms of inferences. And this is based on whether the case assessor or the person sitting behind the case system was actually agreeing or disagreeing with our inferences or not. And that was the critical component of us making sure that the governance around the model was really tight in terms of what was being developed, what was being deployed, and essentially the data science team were able to proactively monitor their performance. So the humans, so to speak, were keeping the AI in check and essentially making sure that we are delivering on a reasonable basis. Now, one thing is for sure, like at a call level, the complexity would have been much higher. And I think that essentially played in our favor, because if you think about it, to take a decision is a lot more difficult as to say, you know what, this sentence is problematic. And as I said, sometimes there were cases where even though the sentence itself was problematic, the conversation might not have been, which is why this was an assistive technology rather than a decision engine to take that call.
Actually, one more question in terms of, I might be cheeky and answer this one myself. But in terms of, is it, there's a question around, is it feasible to use AI to flag calls, emails, and other interactions as part of BAU? And that is correct. So we're currently assisting a couple of organisations with this using a range of technologies, but it gives the ability for a quality assurance over a program or over a call centre, contact centre components, and getting 100% coverage. So we've gone in the past where you'll only do 5%, 10%, or maybe it's 1% of an individual's calls. This is the ability; it gives the ability to do that initial analysis of all the calls, pick up any potential conduct as a result of that. From a conduct issue, but there's the other component that we are finding as well is probably two parts. One is the ability to pick up complaints that organisations may not understand that they're getting as many complaints coming through, and then the other one is in terms of a workplace health and safety issue is that it's able to identify where your contact centre staff are getting abused or harassed by the people making the calls, which is something from an importance for having a workplace health and safety, for making sure that your staff are in a safe work environment. So I think that's the thing. You may not have picked those things up if that had happened. If you're only picking up a limited amount of calls.
Absolutely, and just echoing Brendan's point, I think with the cloud platforms being that advanced, I think the barriers to entry into these technologies have also come down. So it's actually a very reasonable process which can be built into the BAU systems and introduce that high cadence of monitoring conversations in all contexts as well, but specifically in a customer-facing environment where there are a lot of ongoing pressures in terms of performance, as well as Brendan said, like it's a difficult job to be. So it can work both from a customer perspective as well as from an agent perspective to identify focus areas, identify high-risk conversations. So if somebody said something really extreme within a conversation, you can actually flag that proactively to say, this needs to have its own escalation matrix. So the technology is being used in a lot of contexts from a risk and compliance perspective, but it absolutely is relevant from both an operational as well as a customer experience perspective as well.
Okay, so I think, mindful of time. Once again, apologies for the technology. Mess up. Yeah, it was working 5 minutes before we started. But once again, I want to thank Aaliyah, Pratik, and Mike for today's presentation. I know they're all more than happy to be reach out and have any questions if you have any further questions about use cases, the value of the program, and anything to do with that. So if there's no more questions, we can leave it there. Thanks all.
Thank you,
Thanks,
everyone.
everyone.